proofs. So we just learned one of the Pythagorean theorem proofs by using those little squares and cutting them out and using them like a tangram to piece them together. All right, that's not the easiest proof to just remember and know how to do, but there is one proof that is very simple, and I will have you guys memorize this. It's not a hard one. Are we ready? So we know the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared is equal to c squared as long as c is the hypotenuse. You know, because I could really put c wherever I want it to be. So if we're doing A, B, and C, let's say. And so we have a picture, and I would give you this picture if I asked you to do this. And it says, what are two ways to write the area of the square on the left? So the area of the square we can write in two different ways. So first we could do side times side. So what is each side? What's the length along the bottom? A plus b, right? So a plus b. And what's the length going downwards? Still a plus b, right? So one way to write the area would be to write a plus b times a plus b. What's a second way to write the area? A plus b squared. Kind of like a plus b in parentheses squared. Yeah, you could do that. But let's try not to do kind of the same thing that we just did. That's kind of an equivalent way of writing that. Let's use the pieces. Let's use the four triangles and the square in the middle. Okay, so looking at this picture, how do I write the area of this first triangle right here that I just had a little check mark with? How do I write its area? How do we do the area of the triangle? 1/2 base times height. What's its base? What's its height? So it's 1/2 AB. What about this other triangle here that I'm doing a check mark on? 1/2 AB. What about this one? 1/2 AB. What about this one? Okay, so how many of those 1/2 ABs did I have? We had 4 of them. That's correct. So we have 4 of the 1/2 ABs added to the square that's in the middle. So if I have this square in the middle, what's the area of this square? It's c times c, right? So c squared. Perfect. Okay, so that's 2 ways to write our area. So it says set these 2 expressions equal to each other, and we're going to simplify it down. So this is algebra. Yay, algebra. So we're setting a plus b times a plus b equal to 4 times 1/2 ab plus c squared. So when we have a plus b times a plus b, we can't just say it's a squared plus b squared. Do you guys agree? Can't just square each thing. We're going to have to FOIL it out. So when we FOIL it out, FOIL, our first terms make a squared. Our outer terms is ab. That's also my inner term, ab. And my last term is b squared. How about 4 times 1/2 ab? What do we think we get when we simplify 4 times 1/2 ab? 2 of the ab's, right? And then plus c squared. We're almost there. What's 1ab plus another 1ab? 2ab. So we get a squared plus 2ab plus b squared equals 2ab plus c squared. So what's my last step? Yep, subtract that 2ab from both sides, and I get a squared plus b squared equals c squared. Done. Isn't that cool? Yep, and if you look at your little picture here, we have a, we have b, and we have c, right? So a squared plus b squared equals c squared. Okay, everybody get that proof? Could you do that again? Most likely. Yeah, so it's a proof of the Pythagorean theorem. I know I told you you would not have any proofs in second semester, didn't I? That's a kind of a different proof. All right, so Pythagorean triple. So this is a set of 3 positive integers. So underline integers. Do we all know what an integer is? Is 3.2 an integer? No. So integers are like those whole steps, like 3, 5, things like that. You can have negative numbers too, but we're not going to have negative distances. So maybe I should say a set of 3 positive whole numbers. A, b, and c that satisfy the equation a squared plus b squared equals c squared. So an example of this is 3, 4, 5. So I've told you about 3, 4, 5 right triangles. If you take 3 squared and add it to 4 squared, you get 9 plus 16. That's the same as 5 squared. That's a Pythagorean triple. Does that make sense? So there's lots of Pythagorean triples. Okay, so I could do 6, 8, 10. That would also work. Or I could do 9, 12, see, multiply by 3, multiply by 3, multiply by 3, 15. That would also work. These are all multiples of the 3, 4, 5. I think I've mentioned that to you guys before, right? But there's other Pythagorean triples. So after you guys take your quiz today, I'm going to have you guys come up with 5 Pythagorean triples that don't have anything in common. So they don't have, like, you can't reduce them down to all be like 3, 4, 5. Does that make sense?
That's tough.
Yeah. You can look online if you need to. It's a little tricky. Okay, so find the area of the triangle to the nearest tenth of a square meter. Did you discover any Pythagorean triples? So here we might get one. All right, so you guys had a question like this on your midterm where you had to use pieces to get other results. So we're trying to find the area of the triangle. We need the base and we need the height. So right now we don't know the base. So I'm going to call this x and I'm going to call this y. So first I'm going to find x by using the triangle that's on the left. So go ahead and try that along with me. So we have x squared plus 5 squared equals 7 squared. So we get x squared plus 25 equals 49. So when I subtract the 25 over, I get 24. So x is equal to the square root of 24. Yeah, you can reduce it. You could say it's the square root of 4 and square root of 6. Square root of 4 is 2. So we can write 2 root 6. So now we need to find y. So y, we have 5 squared plus y squared equals 13 squared. So I have 25 plus y squared equals 169. When I subtract my 25 over, I get 144. So y is equal to 12. That came out nice and even, didn't it? So what's a Pythagorean triple? Yeah, 5, 12, and 13, right? So that's another one, 5, 12, and 13. So if we want to find the area of the triangle, we do 1/2 base times the height. Well, the height is 5. Our base is a little bit tricky, though, because we had 2 root 6 and we had 12. When we add those together, it is not 14 root 6. So some of you guys did that on your final exam from first semester. You kind of combined things that couldn't be combined. Think about if that had been an x. Like if I had 2x plus 12. 2x plus 12, is that 14x? No, I can't combine those, right? So same thing with square roots. If you have a square root and it's not the same, like it's not like a square root of 6 and the other one has a square root of 6, you can't combine them. So if I have 2 root 6 plus 12, I just leave it as that. I say 2 root 6 plus 12. Okay, so this would be the area. This is the exact value of the area. It's kind of gross. So you could simplify it a little bit by writing like 5 over 2, right? 1/2 times 5, and then 2 root 6 plus 12. And you could even distribute that 5 over 2 in. So if you distribute the 5 over 2 in, you'd get 5 root 6 plus the 2 and the 12 reduced to 6 times 5, so 30. You could have that. Okay, or you can find the decimal version. That's fine. Just round to 3 decimals if you do it. Okay, does this make sense? You guys get it? All right.